All right, so this is question number 9. It's pretty lengthy. It has 31 parts. So to start it out, it says the accompanying table shows the median household income in dollars for 25 randomly selected regions. We're going to complete parts A through G. So we have a table. We're going to open that in just a moment. It wants us to construct a frequency distribution. We're going to use the first class having a lower limit of 35,000 and a class width of 5,000. So in the beginning of the overview, we talked about what the class width was. So we're going to start with 35,000. And then since my class width is 5,000, that means if I add 5,000 to this number, that will give me 40,000. And that will be the lower limit of the next class. And so I will do that all the way down the page and continue to update class limits. So if I open up and look at the data, we're starting at 35, which is a little bit lower than my first term. And it looks like we need to go all the way up to just a little bit around 70,000. So let's continue to do that. I'm going to write down the classes. So we've got 45, then we'll have 50,000, then we'll have 55,000, then 60, then 65, 70, and then 75. Okay, so these will be my lower limits. Okay, the upper limit, what we usually do is subtract 1 from the smallest place value. So if you look at these dollar values, the smallest place value is the ones. So if I were to subtract 1 from the next lower limit, that would give me 39,999. We do this so we don't have overlapping classes. If you were to write 35,000 to 40,000, and then this one started at 40, we wouldn't know which class to classify a number that had a median household income of 40,000. So we subtract 1, and that's how we get it. And then you can just go down this column and add 5,000, and you'll get all your upper limits. So at this point, I'm going to go ahead and switch over, and we're going to input all of these in the computer. So I'm going to do 35 to 39,999. All right, so we also want to count the frequency. So what I'm going to do is open this in Excel, and we're going to sort this data. So here are all the numbers. I'm not sure if they're sorted. No, they're not sorted, so we've got 70. So what I'm going to do is I'm going to go to Data, Sort A to Z, and it's going to do lowest to highest. So now everything is sorted. And then we're going to count how many fall. Sorry, I didn't mean to minimize it. How many, can I move this table? Can't move it. I don't want to make it huge. I should be, there we go. Just want to move it over a little bit. All right, so I want to count how many fall between 35 and 39. There's just one value, so I'm going to put 1 here. All right, so now I'm going to fill in the rest of them. So this is going to be 40. And it doesn't matter if I put the comma, I think it's going to take it. And then if I add 5,000 here, this will give me 44,999. So between those, 1, 2, 3, 4, 5. So between 2 consecutive or back-to-back lower limits, you just add the class width, which is 5,000. Same thing between back-to-back upper limits, you would add 5,000. So that class width should be the same between consecutive lower limits or upper limits. so 45 and 49. 1, 2, 3. 50. And 50 and 54. 1, 2, 3, 4, 5, 6. Alright, 55 and 59. 55 and 59. 1, 2, 3. Alright, so now we're at 60 and 64. 1, 2, 3, 4, 5 in that class. Alright, so now we're going to go 65 and 69. Not typing anything. 65 and 69. And between 65 and 69, we got 1. And then we're going to go 70 to 74, 999, and there's 1. Alright, so now part B wants us to construct a relative frequency distribution using the lower class limit. So we're going to be using the same class limits, except we're going to change the frequency into the relative frequency. So just to do that process a little faster, I'm going to use the calculator we're going to go to stat, enter on edit, and then I'm going to input my frequencies the first time. So my relative frequencies, my frequencies are 1, 5, 3, 6, 3, 5, 1, 1. They already told us at the beginning there was 25 households. So I'm going to go to column 2, go to the very top. Second, tell it list 1. We're going to divide all of those numbers by 25. That's going to give us our relative frequencies. So now, when I come here, I will still put my upper and lower class limits, but this time I'm going to be inputting the relative frequency. It tells us to enter decimals, do not round, so I'm going to use the exact values I have here. Alright, 40, 44, and that is 0.2. And this is going to be 0.12. To the 0.12, 0.24. $55 and 59. 0.12. 60, 64. Too many nines. That's going to give us 0.2. 65 and 69. It's going to be 0.04. And then the last one is also 0.04. So 70,000, 74, so 0.04. Alright, so at this point we want to pick out the frequency histogram. So according to our heights, frequencies, looks like we start low, go up, drop back down, go back up, drop back down, go back up. So it looks like we're doing like this little seesaw motion. And so starting low, up, So these heights look like they represent the frequency of each of the classes that we have established. D wants us to construct a relative frequency histogram. So same thing, just the heights will be the relative frequency. So it's going to be the same pattern. Looks like D again. And we want to describe the shape of the distribution. So we talked about the shapes: uniform, skew to the left, skew to the right, and bell shape. So this appears to be more bell shape. I mean, a lot of them have. When the tail is steady dropping, we can say skewed left or right. And so we're going to say bell shape for this one. Looks like to be the best. All right, so now we're going to repeat parts A through E. So everything we just did up here, we're going to do it again. This time we're going to use a class width of 10,000. So I'm going to do the same process. So what it looks like we're doing is we're going to be combining two classes. So instead of going 5,000 at a time, we're going to be going we start from 35,000? I guess so. We're going to start from 35,000. And then, let me write it out. So if I started from 35,000 and had a class width of 10,000, my next lower class would be 45,000. If I subtract 1 to get my upper bound here, that would give me 44.99. So it looks like we're going to just have half as many classes, probably going to be combining two of those data sets. So I'm going to go from 35 to 44. I got to go to the other box. 44.999. And then the frequency, since I've gone from 35 to here, I'm just going to be adding these two. So this group was 1, this group had 5, and that's where we stopped. So we're going to have a total of 6. So that's going to be my point of reference. So then we will be at 45 here, and we will be at 54 here, and then my next two classes were 3 and 6. So if I add those, I mean, you can use the table. I'm just using the previous information. We had 9 total here. So we're going to be at 55 and 64. So my next two classes would be 3 and 5, so that would give us 8. And my final two would be 1 and 1, would give us 2. So 8 and then 2. 8. And then we're going to go 65 to 74. And there was 2 in those two groups combined. All right, so we're going to do the same thing. We're going to do relative frequency. So similarly, go ahead and pull up the calculator. The same way we added the 2, we'll be doing the same thing with the relative frequencies. Now you can make another chart, but essentially you're just going to be combining the frequency of the two classes. So and that will be 0.24 when you add those two together. We're going to do 45. And that will give us 36. And it's going to give us 55 to 64. And, turned off. So it's here. 1, 2, 3, 4, 5, 6. So we're looking at 0.32. Then 0.04, 0.04, so 0.08. Okay. The histogram, we we had 6, we went up to 9, dropped to 8, dropped to 2. So we're going to start out about a medium height, going to go up, and then start dropping down. So D looks like the answer choice there. And then with the relative frequency is going to be the same pattern. So you start a little bit lower, go up, and then start falling down. So C matches that same shape that we had in D. All right, describe the shape of the distribution. So it still looks bell-shaped. And then does one frequency distribution provide a better summary of the data? Explain. So if you read through the text, it talks about having more classes giving you a better visual. Sometimes when you combine them, it's harder to tell. You might be missing some information. So in this case, they both look the same, but usually more classes is going to be better. So both distributions have similar shape. It works well. Maybe the shape is not clear in the distribution with fewer classes. More should be used. Neither seems to show the shape very well. And then this one says the shape is not clear in the distribution with more classes, so fewer classes should be used. It looks like D, but just from previous experience, they're probably going to be looking at C. So let's check. Although they both look bell-shaped, you really want to have more classes. But let's just look at this. So they don't like that. Yeah, so C is going to be the one. Even though they both look the same, I mean, I could totally see why somebody might pick D. Both of them look the same in this example. But most often, description in textbook, you want to use more classes.